Welcome back. Today we're doing week 2, number 9, middle of the linked list. It's going to be number 876. Middle of the linked list, given the head of a singly linked list, return the middle node of the linked list. If there are 2 middle nodes, return the second middle node. Interesting way to think about 2 middle nodes. I guess this is like when there's a median with an odd number and an even number of elements. All right, let's look at example 1. 1, 2, 3, 4, 5. So the middle node of the list is node 3. Okay, you can visually see that. In example 2, 1, 2, 3, 4, 5, 6, because there's 2 middle nodes, so if you could divide it in half, it would be the first element of the second half. And that could be an interesting way to think about it. How do you divide a linked list in half? So let's think about why this problem matters. So when you have a linked list, you create a node, that's a pointer in memory, and it has typically a next field, and that points to maybe another memory address and another one. And this can go on forever, right? And this is quite different than what happens when you have an array or a list, right? When you have an array or a list, you know, what's happening in your computer is typically you're probably allocating, you know, in memory some block of memory, and that's going to be, at least if you're programming in C, you're trying to have a continuous allocation of memory. Whereas with a linked list, you could be pointing to addresses of memory that are anywhere, could be all over the place. You're letting the OS give you the memory. So for practical purposes for us, in a list, we could do something like, you know, this list, the length of the list divided by 2, and then we can index into the list like this, right? So what the list is doing is it's keeping indexes or indices, and these are attributes on this object, right? This list is an object, and it has an add 0, it has an add 1, has this at 2, it has this at 3, and so on. A linked list doesn't have that, right? Unless we had a tail and a head, there is nothing that is going to allow us to, or even if we had a tail and a head, there's nothing to allow us to divide and then access by index, right? So we need some other mechanism, some other structure, where as we traverse, we're creating our own idea of where things end and where things start. So a lot of times when you're doing these linked list questions, it's going to be about having a pointer and maybe having multiple pointers and traversing them in some clever way, right? And for this problem, what you can do is you can have 2 pointers and have one traverse to the end, and by the time it gets to the end, have the other pointer have your answer, right? So in the case where it's 1, 2, 3, 4, 5, how do we get this pointer up here, this F pointer, at the end, while this pointer, this S pointer, is in the middle? Well, as you can tell from these letters, I'm going to make this a slow pointer and make this a fast pointer. So every time the fast pointer moves, it actually moves 2 steps, right? It goes from here to here, and then it goes from here to here. And every time the slow pointer moves, it's only going to move 1 step. So let's say this is the starting position. I'm going to start this. I guess we can try to do rainbow color. Start this at red. In one iteration, slow is going to move 1. Fast is going to move 2. Slow is going to move 1. Fast is going to move 2. And by the time we get to here, right, so this is the case. So if, fast.next is none, we can just go ahead and stop. What does this look like when we do it for the other one? So let's go back, let's delete these, and let's do the other one, right? Example 2. Slow moves 1. What color should I make this? Make this green. Fast moves 2, right? Slow moves 1. Go ahead and make this, this should have been green. Fast moves 2. Okay, so fast.next is not none. Give me some room here. Let's get a little breathing room. So fast is going to move 2, and then this is going to move off screen, right? And when that happens, slow moves 1. So that works for us. It works for us if we want the slow to be the second of the middle nodes, where if this was a while loop, it would be like while fast is not none, then in fast.next is not none, slow moves 1, and then fast moves 2, right? And what does that mean in code? It's probably like slow equals slow.next, fast equals fast.next, .next, right? So that's going to be the slow one. Go ahead and make this gray. This would be the fast one. And we're going to return slow. Right? So we initialize. Where should I put this code? I'm going to go ahead and delete this. Because I'm using Python, that memory lesson wasn't super valuable because I'm not allocating a set array size. Anyway, let's go ahead and build this. So where do we start? So I guess slow is equal to head, and fast is also equal to head, and while fast is not none, and fast dot next is not none, then we're going to do this iteration. We're going to move slow, and we're going to move fast. So let's think through some examples, maybe some extreme examples where this may break on this, because this is something that we're going to have to do. So what does this look like when there's only one single node? A single node. When there's a single node, slow and fast both are the same thing. Slow here, fast here. We don't do any iteration, we return slow. Is that the right answer? I'm actually not sure, but maybe. Could possibly be the answer. What happens if there's two? So let's say there's two. So slow and fast starts at the same one. Okay. And this one should be the answer, right? The second node. So because fast is not none, fast.next is not none, fast goes up twice. So fast becomes none here. And then slow, oh, so that's an interesting case. So it's an interesting case, and this is why we go through it. It actually matters which one advances first. If fast advances first, slow is kind of left in the dustbin, right? Because our while loop is not dependent on slow. Slow moves first. And that's actually how I have it in the code. So just by chance, I have it correct. Slow moves first, and then fast moves. And then we're done, right? So let's do another one where there's three. Slow and fast start in the same position. If you need a bigger image, it's this one. So slow moves up, 1. The one that should be middle is this. Fast moves up 2, right? And then fast dot next is none. So we stop. So it works for 1, it works for 2, it works for 3. And looks like when we had it here, it works for 5. Right, when we had it here, it works for 6. So let's go ahead and submit this and see how it does. All right. So time complexity, linked list, linear. It's 2 pointers. So I guess you consider it 2 times O of n, or O of n plus O of n divided by 2. So I guess it's 1.5 O of n. And there's not any extra memory. So, there's only a variable for slow, a variable for fast. So basically constant memory. Anyway, when you're doing linked list problems, you're typically going to run into some pointer arithmetic or some pointer juggling. And you're going to think about what is one iteration of the pointers moving? What direction should they be moving? And that's going to help you really far along. All right. See you next time.